Okay, today you will be graphing systems of equations and finding the point of intersection. So a system of equations is when you have a set of two or more equations with the same variables. So right here I have two equations that are in slope-intercept form. They have the same variables, and together they are a system. Now you're going to be finding the solution to systems by graphing, and a solution to a system of equations is the point where that the two lines have in common. So when you graph these two lines, the point where they intersect is going to be the solution. So your solution is an ordered pair. To solve systems by graphing, you're going to graph the equations given. You're going to find the point of intersection, and then you're going to check your solutions. So let me show you what that means. For example 1, I have y equals 1/2 x plus 3. So I'm going to graph this one first. I'm going to start with the y-intercept. My y-intercept is positive 3, so I'm going to place that point right here. And then my slope is 1/2, so my rise is 1 and my run is 2. So rise over run. This will be my next point right here. Alright, so now that I have my two dots, I can connect them and make my straight line. And keep going. Now I'm going to graph y equals 5. So at y equals 5, you're going to, I have my y-intercept of 5 here. And I don't have a slope. My slope is 0, so I have this horizontal line. So this point right here where they meet is going to be your solution. This is the intersection. And the solution for this problem is going to be the point 4, 5. You're going to check this by plugging in your x value and see if you get the corresponding y value. So for y equals 1/2 x plus 3, I'm going to plug in this 4 right here and solve. So y equals, this 1/2 times 4 is equal to 2, and 2 plus 3 equals 5, which is what we have here. Okay, so anytime you put in a 4, your output's going to be 5. And then for this one's easy because it already tells us y equals 5. So since these are the same, then your solution is correct. Example 2, for the first equation I have y equals 4/3 x minus 3. So my y-intercept is -3, so I'm going to start here. This is where I begin, and I'm going to move with my slope. My rise is 4 and my run is 3. So I'm going to rise 1, 2, 3, 4, and then my run is 1, 2, 3. Now I can draw my line. And I can plot the next one. Okay, for y equals -x minus 3, my b is -3 here. And my rise and run, this is the same thing as -1 over 1. So my rise is going to be down 1 since it's negative, and my run is 1. Now that I have my two lines, I can draw them. And my point of intersection is right here at the y-intercept. So my solution is going to be 0, -3. I'm going to check my work by plugging in this 0 for x Anything times 0 is 0. And then 0 minus 3 equals negative 3. So now I need to check this one. Y equals negative 0 minus 3. Anything times 0 is 0. And 0 minus 3 is negative 3. So since these are the same, my answer is correct. Okay, example 3, we're going to do the same thing. So we're going to, this should say x actually. We're going to begin with our y-intercept. So my y-intercept is negative 1. My rise is 2 and my run is 3. So I'm going to rise up 2 and run 3. Draw this line. And graph the next equation. For this one, x equals negative 3. This is going to be the line where all your x values are negative 3. So you have your undefined slope here. And this is going to be your point of intersection right here. So this is your solution at the point negative 3, negative 3. For this one, I'm going to check this by replacing the, okay, so I can replace the x with negative 3. When I multiply this out, I get negative 2. So y equals negative 2 minus 1, and then y equals negative 3. So if I put in a negative 3 here, my y value is equal to negative 3, and that's what I have here for my x and y values. So my solution is correct. You also could check this by replacing, since we have our equation right here as x equals negative 3, what we could do is we could figure out what x equals whenever y is negative 3. This might be confusing, but really what you're trying to do is to figure out if you put in this x value, do you get this y value here for your solution whenever you plug it into your equation. So let's not do that. Right here is the U-try. This is what you're going to do on your own before you come into class, and then we'll talk about these in class tomorrow.